Friends, once again welcome back in our educational channel, that is Milinda's Ideas. Friends, in previous lecture we had studied demultiplexer, and in today's lecture we are going to study the types of demultiplexer. So first of all, what is demultiplexer? Demultiplexer means one into many. It has one input and many outputs, and that input data or input signal is connected to the one of the output terminal, and that output terminal is selected by using a set of select line or set of control lines, and the number of control lines are given by using formula, that is 2 raised to m is equal to n, where m is number of control lines and n are the number of output lines. That is basic about the demultiplexer. Now we are going to study the types of demultiplexers. The types of demultiplexers are: the first type is 1:2 demux, second 1:4, third 1:8, 1:16, 1:32. आणि मित्रांनो, आपण काय किती तो नंबर वाढवू शकतो, 1:32, 64, 128 to 56 as per possible. But in IC, 1:16 demux is a largest multiplexer. In today's video lecture, we are going to study the two types of demultiplexer, that is 1:2 demux and 1:4 demux. So first of all, 1:2 demux. In case of 1:2 demux, it has one input and two output. So obviously, for the construction of demultiplexer, we have to use SPDT switch. The switch is used. Mostly the rotary switch is used, but in this case, as there are two output, single pole double throw switch is used. In this case, the input data or input signal is connected to the pole terminal, and the throw terminals are considered as output terminals, that is Y0 and Y1 respectively. And when we are going to change the lever, position of lever, the input data is connected either to Y0 or Y1 terminal. But friend, this switch is manually operated switch. So in digital circuits, in demultiplexer circuits, this switch may not use because it is manually operated. The speed of operation is very low. So in digital instruments, in digital demultiplexers, we have to use logic ICs as well as the logic circuits. Mostly the basic gates are used. So in first circuit, in the first type, that is 1:2 demux, the two basic gates are required, that is NOT gate and AND gate. The control input is applied to that AND gates through NOT gates, while the data input or input signal is applied to AND gates, and the output of AND gates are considered as output of demultiplexer. Now the circuit diagram of 1:2 demux is going to be displayed on your screen. From this circuit diagram, it is clear that in case of 1:2 demux, the two AND gates are used. The input signal, that is I, is connected to both the AND gates, so that I is common to both the AND gates. The second input for each AND gate is a select input or control input. The control input connected to the first AND gate is connected through NOT gate, so it is a complement of control input. While for the second AND gate, control input is directly connected. Hence, the output of first AND gate, that is the upper AND gate, is given by Y0 is equal to I S complement, while the output of second AND gate is given by Y1 is equal to I S. So that is logic diagram of 1:2 demux. Now how this circuit works? How this circuit connect the input data to particular output terminals? That is first case. We have to study first case. What is the first case? That is when select input, or that is control input, is low. When the control input is low, the upper AND gate, that is the first AND gate, is in enable mode because its control input now goes to a high level. Why it goes to high level? Because the control input is connected through NOT gate. So when the control input is low, when the select input is low, the output of NOT gate becomes high. So the input connected to that gate becomes high. So therefore now output of this gate becomes y0 is equal to I dot 0 complement, that is 1. So y0 is equal to I into 1, so that is I. So now in this case y is equal to I. So whatever may be the signal, whatever may be the data that is connected to the output terminal of first AND gate, that is y0. That is our first case. What is our second case? That is when set input is high. That is when select input is high. When select input is high or when control input is high, the first AND gate becomes disabled because its control input now connected to the low logic. Because 1 is connected through NOT gate, so output of NOT gate becomes low. So the control input of first AND gate becomes low, so that gate becomes disable, is in disable mode, while the second AND gate is in enable mode because its control input is high. So now output of this gate, that is y1 is equal to I dot s. Now s is equal to 1, so y is equal to I into 1. So y1 is equal to I into 1, so y1 is equal to I, or y1 is equal to d. That means from this it is clear that when control input is high, the output of second AND gate is high, so y1 now becomes 1. So y1 now becomes I, that is data. So by using this circuit, the input data is connected to the one of the output terminals, and for that purpose select line or control line is used. That is 1s to 2 demux. The symbol of 1s to demux is going to be displayed. It has one input, two outputs, that is y0 and y1, and there is one select line. Now the truth table. What is truth table? It has only one control input, so it is a S and output. When S is equal to 0, y0 is equal to I, and when S is equal to 1, y1 is equal to I. So that is 1s to 2 demux. Now we are going toward the next type, that is 1s to 4 demux. Now in case of 1s to 4 demux, once again basic demultiplexing action is obtained by using a rotary switch. In this case, as there are 4 output, SP 4-way switch is used. Same as multiplexer. In multiplexer, in case of 4s to 1, in case of 4s to 1 mux, SP 4-way switch is used. In this case also, it is 1s to 4 demux, the same SP 4-way switch may be used. But in this case, the input signal that is connected to the one of the output terminal is connected to the pole. SP, single pole, is connected to the pole terminal. And there are 4 ways are considered as output terminals y0, y1, y2 and y3 respectively. And when we are going to change the position of that shaft or lever, the input signal is connected either to y1, y2, y3 or y1 terminal. So that is once again a manually operated demultiplexer. So in logic circuit, in logic instrument, this rotary switch may not be used. So in logic circuit, in logic instrument, we have to use demultiplexer in form of IC or demultiplexer, which is constructed or which is assembled by using basic gate, by using logic circuits. So in this case, as there are 4 inputs, the 2 control lines are required. As there are 4 outputs, the 2 control lines are required. 2 raised to n is equal to n is equal to 4 outputs. So the 2 control lines are required. And as there are 4 outputs, the 4 AND gates are required. The input data, that is I or that is D, is common to all that AND gates. And in this case, 3 input AND gates is used because there are 2 control lines, that is a S0, that is S1 and S0. So there are 2 control lines and 1 data input. So in this case, 3-bit AND gate is required. So input for first AND gate are, that is data, and output of both the NOT gates, because in this case the control input is applied, it is directly connected, or in some cases it is connected through NOT gate. So the input for first AND gates are I, that is data, and complement of S0 and S1, that is output of both that NOT gates. So the inputs are I, S0 complement, S1 complement. So output of this gate is Y0 is equal to I, S1 complement, S0 complement. For second AND gate, the inputs connected are I, that is common, then S0 and S1 complement. For third AND gate, that is I, S1, S0 complement, while for the fourth AND gate, it is I, S1 and S0. So what is the output of each AND gate? The output of first AND gate is Y0 is equal to I, S1 and S0 complements. The complement of S1 and S0, so I, S1 complement, S0 complement. Output of second AND gate is Y1 is equal to I, S1 complement, S0. Output of third AND gate is Y2 is equal to S1, S0 complement. And output of last AND gate, that is the fourth AND gate, is equal to Y3 is equal to I, S1, S0. So that is 1:4 demults. Now the working of this demultiplexer. First case. Sorry. What is the first case? First case, that is when both control inputs S1 and S0 are low. So when both control input S1 and S0 are low, the control input terminal of first AND gate becomes high, because S1 and S0, the complement of S1 and S0 are connected to the first AND gate. So the first AND gate is in enable mode, while the other three AND gates are in disable mode. So therefore that data is connected and fed to the output terminal of first AND gate. So in this case, the Y0 is now equal to input or is equal to data. So that means when S1 is equal to S0 is equal to 0, Y0 is equal to I, or Y0 is equal to D, that is data. Second case, when S1 is equal to 0, S0 is equal to 1. So in this case, the second AND gate is in enable mode because its control inputs are connected to the high logics. So the second AND gate is in enable mode, while other three AND gates are in disable mode. So the input data is now connected to the output terminal of second AND gate, that is Y1. So in this case, Y1 is equal to I or D. That means when S1 is equal to 0, S0 is equal to 1, Y1 is equal to D or Y1 is equal to I. Next, third case. That is when S1 is equal to 1, S0 is equal to 0. So in this case, the control input terminal of third AND gate becomes high. So the third gate is in enable mode, while all three gates are in disable mode. So now in this case, the data, that is a D or input signal, is connected to the output terminal of third AND gate, that is Y1. So in this case, Y1 is equal to 1. That means when S1 is equal to 1, S0 is equal to 0, output Y2 is equal to D or I, that is input. Now the last case, that is the fourth case, that is when both S1 and S0 are high. When both S1 and S0 are high, the fourth gate is in enable mode, while the other three AND gates are in disable mode. Hence the data, that is the input, is connected to the output terminal of fourth AND gate. So output of fourth AND gate, that is Y3, now becomes high. Y3 is equal to I or Y3 is equal to D. That means when S1 is equal to S0 is equal to 1, Y3 is equal to D or I. So friends, that is 1:4 demults, in which there are one input, two control inputs, and there are 4 output terminals. So that is 1:4 demults. The symbol of 1:4 demults is going to be displayed on your screen. The symbol में आपको लगता है it has 1 input, 4 outputs, and there are 2 control lines or 2 select lines. What is the truth table of 1:4 demults? The truth table, there are control inputs. There are 2 control inputs, that is S1 and S0, and output. When control input S1 and S0 both are low, Y0 is equal to I, or it is a D for data, I for input signal. So Y0 is equal to I. Second, when control input S1 is equal to 0, S0 is equal to 1, Y1 is equal to I oblique data. Third case, when S1 is equal to 1, S0 is equal to 0, the Y2 is equal to I or D. And last, when both control inputs S1 and S0 are high, output Y3 is equal to I or Y3 is equal to D. So friends, that is 1:4 demux. So thanks for watching this video lecture. In next video lecture, we are going to study demultiplexerizing. So once again, thanks for watching this video lecture. Bye. Take care. See you again.